So hello friends, today we will understand what is 3' end and 5' end of DNA structure. So when we consider a DNA structure, we know here as this is the DNA structure. So you know there are three different elements which combine and form a DNA structure. Like there is a phosphate group. This is the phosphate group. And there are sugar bases. This is the sugar bases. And we also have a nitrogenous bases. This is the nitrogenous bases. Okay. So these three different elements form a DNA structure. How? You know that sugar bases has different carbon compounds and there are different prime ends. Okay, like if you consider this as to be the sugar base, so here one carbon can come, here another, here another, like that we have 5 carbon attaching side and those are known as prime. Okay, suppose this is the 1 prime, this is the 2 prime, this is the 3 prime, this is the 4 prime, and here we will have the 5 prime, like that. So this way carbon gets attached, and you see the phosphate group always attaches with the 3 prime end of the previous carbon of the sugar base. Okay, and here also you see here 1 prime, 2 prime, 3 prime, 4 prime and 5 prime. And see 5 prime and the 3 prime is always attached with a phosphate group. See here previous one is attached with this phosphate group, and in the later one you will see the 5 prime end is attached with the phosphate group, and this way it gets synthesized like that. Okay, adding different nucleotides. These are a nucleotide. When you consider a nitrogenous base, a sugar group and a phosphate group, these three together makes a nucleotide. Okay, nucleotide. And when we remove the phosphate, when you consider only the nitrogenous base and the sugar, we consider that as a nucleoside. When you remove the phosphate group and when we take only the nitrogenous bases and the sugar, we know that to be the nucleoside. And this, when we consider the phosphate group also, these three elements form together from the nucleotide. Okay, so today we will know what is 3' and 5'. So as I have already mentioned here, the 5' end gets attached with the previous phosphate group, previous nucleotide. Okay, so when there is no nucleotide sequence out here, you will see this 5' end is free, right? So when you draw here 2 DNA strands, this is one strand and this is another strand, like that. Okay, so when you consider this, you will see here the 5' end. So the 5' end here means this 5' end, and the 3' end here means this 3' end. You see here the 3' end is free, right? And this 3' end, when it gets another when it gets another nucleotide sequence out here with the sugar bases, you will see here it will pair with the phosphate group of this and 5' of the later sugar base. Okay, So this way it goes on, and so you will see here the 3 prime and 5 prime here, and even in the opposite side you will see if this is a 5 prime, then the opposite complementary strand will have 3 prime free. So here you will write 3 prime and here you will have 5 prime, because both DNA strands are anti-parallel. Okay, they are not parallel. So here you will see 1, 2 and 3 prime here, and this 3 prime is free, and they can again attach with a phosphate group out here. Okay, like that, and here they can synthesize the strand. And even here you will see, if you consider this to be 1 prime, it will be 2 prime, it will be 3 prime, 4 prime, and this is the 5 prime. So this 5 prime is free and it will get attached with a phosphate group out here. But we know that in DNA the synthesis always occurs in the 3 prime end, not in the 5 prime end. Okay, so this is what is meant by 3 prime and 5 prime end of DNA.